This is the Excel spreadsheet for the data using bioelectrical impedance, the handheld bioelectrical impedance, to calculate out or to measure percent body fat from some college students in our XPhys labs last year. And here, the first column is the subject number, male or female, and here is their body weight in pounds. And you'll need to have Excel calculate out their body weight in kilograms, their fat-free mass or lean body mass in kilograms, and their fat mass. So some of you may know how to use Excel very well. Let me show you how I use Excel. And I'm on my Mac computer, so some of the commands may be slightly different. I also have an older version of Excel, so the commands may be slightly different, but they're there and you can look and see. So I want to convert body weight in pounds into body weight in kilograms. You need to know the conversion, and the conversion is to take pounds and you divide it by 2.2 or approximately 2.2. So I want to take 133.1 and divide that by 2.2 to get body weight in kilograms. So to do a calculation, you always type in equal sign. So that is telling Excel that we're going to do a calculation. And then I want to highlight this cell. So I'm taking C4, cell C4, and I'm going to simply divide that by 2.2. There. And so this person weighs 60.5 kilograms. And then I don't want to do that calculation every time. So at least on my computer, I can take my cursor and I go to the bottom right corner and it changes shape. It's now like an X. And I can just drag this command all the way down. And so now I calculated, or had Excel calculate out all the body weights in kilograms for all of our volunteers. So you need to figure out how would you calculate out fat-free mass and how would you calculate out fat mass. And then tell Excel to do those calculations. And I think if you think about it, logically, you'd figure that out. If this person, subject 1, weighs 133 pounds or 60 kilograms and is 17% body fat, so all we want to do is what is 17% of 60.5. So you're going to take 60.5 times, and as a decimal, 0.1730, and that would be that person's fat mass. And then everything that is left over is their fat-free mass or their lean body mass. So you need to do those two calculations or have Excel do those calculations and drag those down all the way for the males and females of these class sections. And then you want to calculate out an average and standard deviation, because that is what you're going to put in the graph, and that is what you're going to put in a table. So how to calculate out averages, and I've just remembered these commands. So here we want the average for females. So I'm going to enter equal sign, and I know the command is average. So you just type out average, and then it's asking for what numbers do I want to average. So I'm going to put in open parentheses, and I'm going to highlight all the females in the class. So that was all the way down to there. And then close the parentheses and hit enter. So that was the weight in pounds of all the women in the class. And then what is the standard deviation? What is the variability of their body weight? And the command for standard deviation is STDEV. I've just sort of memorized that. You can look it up if you need to. But it's STDEV. So it's Excel knows that I'm looking for a standard deviation, and I'm going to do open parentheses, and what numbers do I want to look at? That's all the numbers of the women in the class section. Close parentheses and hit enter. So the average weight in pounds was 133 plus or minus 17.66 pounds. And we'd like these things in kilograms, so we're just going to take this and drag it all the way over. So their weight in kilograms was 60.5 plus or minus 8, and their percent body fats, and that's what you're going to be plotting, is 20.6% plus or minus 4.27%. So you'll need to do the averages for the male and the standard deviation for the male, and then also complete these two columns for fat free mass and for fat mass with the units of kilograms. So this was a brief description of the data. Here's the lab video that I just made explaining sort of the requirements for this lab, and I'll actually move it into our lab content folder in here. I put it in the wrong place. And here is back in the content folder for this lab report. One other video that you should look at is this body composition lab PowerPoint with voiceover. And the lab TA students for last spring semester did this. And so it will download on your computer as a PowerPoint, and it's going to automatically have some voiceover. So Ben and Seth described what was going on in this PowerPoint. For our summer class, I changed things a little bit than what they did in the spring, but they came up with some really nice guidelines for this body composition lab. And so for your lab report, we used bioelectrical impedance. So that is your method section of the lab report. So this briefly describes it. And there's a video that describes it even more. And here's some guidelines using body fat analysis. So one part of your discussion is what are some limitations. Now we did not control for all these things when we tested people in our XPhys class last year. I mean, we don't really know what they ate or drank 4 hours before the test. So there's a lot of limitations to this bioelectrical impedance method. So one other video to look at that has voiceover, and they did a nice job. So here, like, is a little icon, and it should just automatically play, is to look at this body composition lab report voiceover that they described. So a lot of things to do for this lab report, and again, I would like you to cut and paste everything into this document, and hopefully you can cut and paste even the graphs, so they would go into this results section. If you can't, you can leave them in the Excel file, but it'd be nice to put them into this Word document. So for your turn-in lab, you'll turn in this Word document with your information at the top of the lab, and then here at the bottom of this lab, you're going to write up a lab report. So it's going to be a pretty long document. And then you also will turn in your Excel file with your calculations and with the graphs that you made and maybe the table that you made. It's pretty easy to cut and paste graphs and stick them into this Word document, and that would be nice. So I think both the previous video and this video will give you some nice directions on what is required for this turn-in lab. And so it's more points and it's more work, and hopefully these directions will help you submit the best possible lab report that you can.